you are.
Lovely. Well, Dr. Gerald Pollack, thank you so much for coming on the show.
It's my great pleasure to be here, or
Well,
there, wherever we are.
Exactly, wherever this conversation is taking place right now. You have a very interesting worldview that would surprise a lot of people, because I don't think people have looked at water and thought about the different phases it can come in. For someone who is new to the phases of water, what do they have to unlearn?
Particularly if they're biologically or medically oriented, they have to learn that water is not an incidental bystander in the picture of life, or the drama of life. Water is a protagonist, and the thought that people learn when they read the textbook is that water is merely the background carrier of the more important molecules of life. It just sits there, and it's a solvent. It's a solvent for proteins and nucleic acids and such. That's what you learn. We found that that's absolutely not the truth. It's really the opposite, that water is in fact central, absolutely central to all that goes on inside your body.
Okay.
So I mean, that I think that's probably you might consider that to be the main the main point. Of course, there's a lot to say beyond that, but that encapsulates, I think, it's not only a central player, but it's also an energetic source for our body.
Okay.
Now,
Oh, sorry,
we don't.
I was just going to just add off what you said, which is okay. So if someone who's not familiar with the work is hearing that, they might think, okay, so it's important just to stay hydrated, and then that's done, right?
It's absolutely important to stay hydrated, but hydration inside the cell is different from what we think of hydration. We think of hydration as taking a glass of water and making sure that we're well enough hydrated. But what happens is the water that we take in, whether it be by drinking or from the atmosphere or as part of food, much of that water gets, you might say, transmuted into a different kind of water. We think of water, or I should say, chemists think of water as a bunch of H2O molecules that are bouncing around randomly and at a fierce rate. But there's a different kind of water. We call it fourth phase water, because we all know the three phases: the solid, liquid, and vapor. But this is yet another phase. It's a water that's different. It's a water that is kind of like a liquid crystal, in which the molecules are ordered in some way. And by virtue of the ordering of the water, the molecules have a tendency to stick together. And because they stick together, this water has a highly viscous consistency. That is, it doesn't flow like liquid water. It flows. It kind of doesn't. It flows like a raw egg. For example, if you think of a raw egg, which is, you might say, a pre-cell, it has that consistency, or exactly that consistency as a gel.
Okay.
Yeah, and will say a lot more if you just ask me.
Okay, wonderful. Well, I think the next sort of corollary to that, just as if we're sort of building the structure of someone who's listened to this first time, I guess the next question would be around why that fourth phase, this different structure, is significant in our human body.
Well, it's significant because first of all, it's what fills our cells. So our cells are not full of liquid water. If you cut your cell, or let's say, suppose you're brave enough, and I believe you might be, to take a razor blade and run the razor blade along your forearm, so you cut yourself. You're cutting through cells, and if the interior of the cell were liquid water, and you cut yourself, the liquid water would come pouring out. But as you know, it doesn't come pouring out. Blood comes out. But on the other hand, the water stays in. And you hear the same pretty much from surgeons who cut deep into the abdomen. I have a couple of surgeon friends, and they tell me, they'll cut through the belly of a muscle, and you expect that all the water in the cells would come pouring out, but it doesn't come pouring out. You see, it stays in because the water is not really liquid water. nor is it solid water or ice, and nor is it a vapor. It's something different, and that's why we've taken to calling it fourth phase water, because it apparently is a different phase of water.
Mm.
So yes, I don't.
That's a great example. That perfectly hangs it for me. I'm like, okay, well, intuitively, I've just found out about this new phase of water, and then I have an example where I can understand how that actually operates. Right? Everyone has experienced.
Well, it's not a new phase. It's been around for a while. It's
True.
newly
Yes.
discovered phase. Yes.
Newly
Okay.
discovered phase. Okay. Yes. So it's negatively charged. It's more structured. It behaves like a crystal or a gel.
Yes.
What are the conditions where this water forms, and I guess where does it show up in the human body?
Well, um, there are two or three main conditions that facilitate its growth. First of all, it occurs when water, ordinary liquid water, meets a surface. The surface has to be hydrophilic, that is, water-loving surface. For those who are less familiar, water-loving surface is a surface. If you have a horizontal surface and you put a droplet of water on that surface, the water spreads out. That's hydrophilic, as opposed to, say, a Teflon surface where the water beads up. That's hydrophobic, fearing, water fearing. So the water fears it, and it kind of scrunches up into a little ball. But we're talking about surfaces where the water spreads out. That's the first. The second is you need energy to create this, because the water undergoes a significant change, and to power that change, you need energy. And it took us a long time to figure out what is the energy, and it was identified by a young undergraduate student. I never did find out whether that student was bored with what he was doing and tried something new, or uh, whether he was really curious. So he was doing an experiment in an experimental chamber, sitting on a bench, um, and we could visualize this fourth phase water, or we call it also EZ, or exclusion zone water. I'm not sure it works in England. It's EZ, I think, isn't it? Instead of EZ. We say,
Easy. No, we'd say easy. Yeah.
oh, you do? Okay, so
Yeah. Yeah.
easy is easy to remember. So
Yeah.
that that name kind of stuck, and we called it that, exclusion zone, because as a liquid crystal, it tends to exclude anything that's inside the water to begin with. In order to form a crystal or a liquid crystal, it's got to push out all the contaminants, so it excludes. And we did this experiment where we took a chamber, experimental chamber, and we put water in it, and we added tiny little particles called microspheres, commonly used in science, and we plunked a small gel into the water, and we found right away that adjacent to the gel, to each and every surface of the gel, the microspheres tended to vacate, disappear, get excluded from the region next to the gel. That's why we called it exclusion zone. So this student
Mm.
was doing that kind of experiment, and he noticed the way very many of us have noticed, that the exclusion zone builds, and it typically will build to maybe a third of a millimeter or a half a millimeter or something like that. You can see it with your naked eye. It's really quite macroscopic, and it builds layer by layer. We found out later, each one being a kind of a, I guess, hexagonal or honeycomb layer, and the first layer builds from that hydrophilic surface, and then it acts as a template for the growth of the next layer, which acts as a template for the growth of the next layer, and so on and so on. And you get typically on the order of 1 million layers. It's pretty macroscopic. Um,
Wow.
so anyway, so the student was playing around with this, and he noticed that sitting next to him was one of these gooseneck lamps. So he grabbed the lamp, shined it on the chamber, and the region that was illuminated, the exclusion zone grew. It grew by 3 times or 4 times or such. It was really major. It was not subtle. He called me because I guess he was as surprised as I was. He said, "Take a look," and I took a look, and I was astonished because I thought, my goodness, this guy has the answer. It's light that is responsible for supplying the energy for growth. It's kind of like in plants. The first step of photosynthesis is pretty much the same. It's light that does it. So we studied. Uh, we then did actual real experiments to find out which wavelengths of light, and we found that the most powerful wavelength was in the infrared region. Some red could actually expand the exclusion zone, but much more powerful was infrared light. Um, that's what that's
Wow.
what we found after he did, and so that's one of the conditions. So you need, your question was, what are the conditions? The first condition is that you need a hydrophilic surface. Um, there's a caveat I'll get into in a moment, but basically you need a surface, and you need infrared energy. But infrared energy is all around. You can turn off all the lights in the room, complete darkness, and you whip out an infrared camera. That is a camera that's sensitive only to infrared wavelengths, not to visible wavelengths. So you can't get an image as you might get on your cell phone camera. But with all the lights out, you can get a beautiful image of everything around you. Your wall is pretty blank, so you might not see a whole lot, but my wall is not, and you'd be able to see everything on the wall. And the military uses it to see at night, to check out the enemy tanks and such. So everything is generating infrared energy or light. And so the energy required to build the EZ is there. Okay, so that's one story. But another story, we found that if we take ordinary water, don't need a hydrophilic surface, just ordinary water, and you stick an electrode in and pass electrons, that is current, into the water, what happens is the region around the electrode converts from ordinary liquid water to EZ water, negatively charged. Well, I should say, I have to talk about the charges, but it's negatively charged EZ water. Now, what about those charges? We didn't talk about charges. And you start with ordinary water, and ordinary water is not charged. It has zero charge, or, to a first approximation, zero charge. And we kind of were playing around in the laboratory, and we stuck an electrode, or a pair of electrodes, I should say, with one electrode sitting in the exclusion zone in the fourth phase, and we were shocked, so to speak, if you pardon the expression, shocked to find that it was negatively charged. Now, if you scratch your head for a moment and think, this is impossible. How on earth, you start with neutral water? How is it possible that neutral water can suddenly become negatively charged water, or some variant of water? And we were stymied, but then we reasoned the only possibility that we could think of is that somewhere else in the chamber there must be positive charge, and we found it. So what we found, to summarize, is that you've got a hydrophilic surface here, and then right next to the surface builds this negatively charged EZ, and beyond it are positive charges. And the way this works is that the water molecules gather here next to the hydrophilic surface layer by layer. And as they do, each water molecule that's part of this casts off a positive charge. So this becomes negative, and the region beyond becomes positive. And it remains that way for any length of time. Uh,
Wow.
and so you've got a battery.
So, I guess easy water in the cell functions like a battery does. It's
Yes.
charged, right? And when it's expanding, it's fully charged, it's ready to go. And when it's shrinking, it's lacking energy. Is that right?
Well, I'm not sure what you mean by when it's shrinking.
I
It
guess.
can deliver energy. Um, yeah, I mean, basically it's charged. The EZ is negatively charged, and the region beyond, which is basically protons stuck in water, or
Hmm.
hydronium ions, as the chemist would have it, because the protons stick to water molecules, forming hydronium ions. So you've got negatively charged EZ water, and you've got positively charged hydronium ions. And we to obtain proof of principle that this actually is a battery, we stick two wires in, one wire in the negative EZ, another wire in the positive region next to it, and we can draw current enough to light, for example, an LED lamp. Um, so
Wow.
it means it's really happening. We're really getting electrical energy from water. We don't expect that the water can store energy and deliver energy, but it actually can. Um,
So,
we
so if the, uh, I guess this fundamentally shifts the model of how we view the human body and how energy is created around the body. What implications does that have on human health?
um, Serious implications on human health because we established that paradigm for action in the cell. I'll explain what I mean by action. Has to occurs by virtue of this easy water transitioning or undergoing a phase change, so to speak, to ordinary liquid water, and then back again to complete the cycle. So, for example, if you're talking about a muscle cell, so muscle cells sometimes they're contracting, sometimes they're not contracting. So, if the muscle cell is not contracting, we found that the water inside the cell is this easy water that we're talking about, almost all in a healthy muscle cell or other kinds of cells. It's easy water. But when the muscle is triggered to contract, what happens is a massive change occurs, a so-called phase change, which biologists are not so familiar with, but physicists and chemists deal with phase change all the time. Um, so what happens is this easy water, which fills the cell, undergoes a change to ordinary liquid water, and the proteins that are inside the cell, um, they also undergo a change because previously this easy, structured, easy fourth phase water was constraining those proteins to be in their extended state. But when the water changes to ordinary liquid water, then those molecules are free to do whatever they want, and they undergo a conformational change to another state. And that conformational change is what brings about the contraction. So,
Right.
as an example, in a say a secretory cell, same thing happens, and it's the conformational change in the protein that propels the secretory action, et cetera, et cetera. So this is a general paradigm that exists, and we've established that it happens in at least a half dozen cell types, and by implication, it probably happens in most or all cell types. That the action occurs by virtue of a phase transition where the water and the proteins change, and that change precipitates the cellular action. Now, this paradigm, um, I think we've pretty well established it. And it's so different, so completely different from what you learn in the textbooks, um, that I'm not sure. I'm not sure what to say exactly, but if we're right, then pretty much all of biology is wrong. Uh, I hope that answers your question somewhat.
It
Probably,
absolutely does. It
yeah.
absolutely does. The and I'm pretty sure Gilbert Ling's a big influence of yours.
Well, yeah. Everything that we've done is built stands on the shoulders of Gilbert Ling. So
What was the
uh,
insight that Gilbert Ling had that I guess led to you discovering what you've just discovered?
Gilbert Gilbert was a super talented investigator. He came from China in 1948. There were four people chosen from throughout all of China, the most promising scholars to study in the U.S. Um, after the war. Three of them, out of the four, three of them won Nobel Prizes, mostly in physics and I think chemistry. And Gilbert Ling, by virtue of his monumental contributions, should have won probably 2 Nobel Prizes. Not for peace, because he was not necessarily a peaceful guy. He tended to be a bit strident sometimes. But anyway, I met him at a conference in Hungary. The conference was to commemorate the life of a famous Hungarian biophysicist named Ernst. And Ernst had 2 interests. One of them was water, and the other one was muscle contraction. And he took a contrarian view in both areas. And so at the time, I had been studying muscles, and they invited me to present something on muscles. And, I did my job, and I think it went pretty well. But I met Gilbert Ling there for the first time. And Gilbert presented his work on water in biology. And I was blown away by his presentation. He said that in cells, in biology, water is not like water in a glass. He said the water molecules are ordered. So if you can imagine a water molecule like a dipole, like a bean with plus at one end, minus at the other end, these dipoles can stack on one another, minus to plus, and they could stack for quite a distance. And he said that because of this stacking propensity, that the water inside the cell, the molecules of water are stacked that way. And he presented mounds of evidence to support his point of view. Well, I was just mesmerized by it, and I came home to Seattle. I don't trust myself because I'm maybe easily mesmerized. So I gave one of his books to several of my students, who, among the more astute students, and they fed back to me and they said, if this guy is right, everybody else is wrong. Because if the water is ordered, then, which he was espousing, then the molecules can't move around easily. Ordered water is a bit like ice. Things are pretty static. So there's got to be a different kind of mechanism. And they said not only is this a revolutionary idea, but he's presented mounds of evidence in support of the idea. So I couldn't resist changing fields. We were doing pretty well in the area of muscle contraction. I can't say that that the whole field, that we swayed the whole field into a paradigm that I still think applies, not the presently accepted one. But we were having a good time, and we were reasonably well supported and making progress. And I was cranking out students who got prominent positions around the world. And but I couldn't resist changing fields because this was too interesting. So we started with Gilbert Ling's ideas, and the first experiment, we after we were able to get a bit of money to support the experiments, we confirmed that there was a kind of ordering. And from then on, we deviated. We found, the fact that, Gilbert Ling argued that they were simply water molecules that were stacked on one another. And we found that wasn't the case, because those molecules were negatively charged, which means that there had to have been some kind of I hesitate to use the word transmutation, because that's not really a transition to some other kind of water, and this battery-like effect that we found. And so we deviated, and I made enemies with Gilbert Ling. I didn't want to, but Gilbert, I think he was resentful because he was largely ignored. And I had written a book. First thing I did was to write a book called Cells, Gels, and the Engines of Life. And the first half of the book was designed to convey Gilbert Ling's paradigms, ideas, in a way that people could digest, because his writings were practically indigestible. You had to be an expert's expert in order to get through it. And I thought I would be doing him a favor by presenting his ideas, clearly his ideas, uh, in a way that people could appreciate or understand. But he didn't see it that way, and he complained and advertised to many people uh, in the water world, so to speak, uh, that I didn't quote him enough in the book. I think he wanted me to mention the name Gilbert Ling in every paragraph. And although I thought I made it abundantly clear that this was not my idea, these are his ideas,
Mm.
uh, from which we. So anyway, it took a decade, and finally, when we demonstrated clear evidence for long range ordering of water. I remember distinctly. He was sitting in the audience, and he popped up and shouted, "Oh, this is the best thing ever since the invention of the wheel," or something like this. So finally, in his later years, we did make friends again, and I appreciated that because obviously, in theory, there ought to be, we're allies, or we're going in the same direction. Some deviation of ideas, but the main point is that Gilbert Ling was really a mentor of mine. He died 5 years ago at age close to 100, so he
Wow.
lived a full life and a productive life. He did make enemies, not only among his detractors, of which there were many, but also sometimes among his friends, because his personality was could be a little difficult at times.
Mm. It's often
Anyway, he's my hero.
it's often the case
It's
with brilliant people like that, right? There's
often
yes.
it's uh, but the bottom line is, as I said, he's a hero, a great hero of mine.
Mm.
Um, and
So
yeah, go ahead.
so you were obviously greatly inspired by Gilbert Ling.
Yes.
You reference, was it Newton's I've stood on the shoulder. If I've seen further, it's because I've stood on the shoulders of giants, right? So but you knew him as a person as well. I'm curious how uh, watching him as a person and how you show up in day to day life, knowing what you know and knowing what Gilbert knew. How does that change how you live on a day to day basis?
Uh, well, that's an interesting question. Uh, uh, One that I hadn't thought about. So therefore, it's a very good question. Uh, well, there are a few things. I guess the first is it drilled into my head the fact that if you run against the mainstream, you run against obstacles. It's never easy. It's not like Bruno and 500 years ago, whatever it was, getting burned at the stake for his belief system. We don't get burned at the stake anymore, but um, we it's easy to become unpopular, and I've suffered in my own department. There are forces that have conspired against me, and I think in unreasonable way. Some of the activities are sort of kindergarten-like activities that are perpetrated against me. But I take it in stride. Because I understand that this is typical over the ages, that if you espouse a view that is contrary to the prevailing view, they don't like you.
Mm,
I used to be really popular in my department, and when I switched from muscle contraction to water, I suddenly became really unpopular because I was stepping on fragile toes.
mm,
So that's one thing, and the second, I guess, how does that affect my daily life, is to press on. Um, and I've become passionate about finding truth in nature, and I've found or discovered that a lot of our thought patterns, or um, paradigms, I should say, in science, I believe are wrong, and we accept something that's been in the textbook for 2 generations, or 3 or 4, or even 5 generations. We assume it must be correct because otherwise it wouldn't be in the textbook for 5 generations. But I'm not so sure. I remember in graduate school trying to understand about the kidney and how it works. I couldn't figure it out. I read the textbook chapter again and again and again, and I simply couldn't get it. And I assumed that, well, everybody else must get it, and therefore and my mental capacity must be limited. I'm simply not smart enough to get it. And I've come to realize that while that might be the truth, that might be the case, often the paradigm may be wrong, simply wrong. And there's no reason that you can understand it because it's not right. And uh, I've been following that course of belief system or such now for quite a few years, even well beyond water. Um, and when I see something in the textbook that looks really complicated, and I have to read it 3 times to get it, and I still can't get it, I've come to realize that it might be wrong. It might be simply wrong. And there are so many of those paradigms. So, for example, I have a book just sent to the printer in South Korea, just sent last week. And so the book should be out. It's called Charged. That's the main title. And subtitle is the unexpected role of electricity in the workings of nature. And I deal with phenomena we see every day and we think we understand, but I demonstrate that we don't really understand because there are observations that simply don't fit the accepted paradigm. And I deal with a wide range of subjects, ranging from what turns the earth every 24 hours, to what creates the wind, to what creates the weather from first principles, to the nature of gravitation, to how birds fly, how planes fly. And it will surprise you to hear that the experts admit that they really don't understand how planes fly. There are some ideas that float around, but these guys who just wrote an article for Scientific American, um, in the title is something like "How Planes Fly," and the subtitle is "Despite years of study, we still don't understand." That will surprise you, I'm sure. But
Mm.
and so I deal with that subject. I deal with how fish swim, and a whole bunch of other things that we think we understand, but like fish swimming. So if someone were to ask you how do fish swim, you'd probably say, well, they flap their tail, or you might say they undulate their body. Both of those are accepted theories, but if you go into it one step further, you realize that there's something fundamentally wrong with both of those ideas, and so I think the answer lies elsewhere. I won't divulge what my views are because the book will be out in about 6 weeks, I think.
Okay, great. We'll put a link to the book in the show notes when this goes out, and
Oh,
people
thanks.
can, yeah, well, people can go and check it. I mean, I'm curious. You've got me right. I want to know what causes it. It's a good segue to electricity, though. Actually, before we get to electricity, off your, I guess, having conviction in a non-consensus viewpoint, when the world is telling you you're wrong and laughing at you and you're holding true, I think takes a lot of conviction. And I'm convinced it's a gene. I think some people have a gene that lets them stand outside the herd and feel less pain than others would. And I think there are a lot of great scientists. I think a lot of great entrepreneurs and investors as well, because it's one and the same thing. My day job as an entrepreneur, and you can't play that game without a non-consensus view that turns correct. Because if it's consensus and correct, someone's done it. And if it's off consensus and wrong, well, it's wrong, right? No one wants it. So yeah, I definitely admire that. It's an interesting thing for sure.
Well, I'm not sure what more to say. I don't know if I've got that, but I guess one element that's required is a bit of confidence, and I think most of us start without that kind of confidence. But with the years and some positive history, you gradually gain that confidence. And now I'm not fearful of saying, for example, that the model of the atom that we all grew up with is wrong. And I've got a book waiting to be published on that subject as well. It's not the sort of thing that most people are feel confident enough. But when you add 2 plus 2 and you get 5, something is wrong, and you gotta go back and take a look.
Yeah.
And with the model of the atom, as audacious, you might say, as that is the case. There are some obvious flaws in the model that you have to take into account, and I've done that. The surprise, the surprise is that the model that I wound up with is not so different from the model that several prominent chemists 100 years ago said this is the way it is. It's not. It's not the way that Niels Bohr suggested, like the spherical nucleus and the electrons uh, around it. It's different. So I felt when I found out that that was the case recently, I was really buoyed by that observation because these chemists, they said, "Oh, this model that's come out, model of the atom, um, it's the physicists who came up with it, and the model doesn't explain the simplest of chemical reactions. Therefore, it can't be right." and um, and they're right about that. I mean, if you can't explain the simplest of chemical reactions, perhaps there's something wrong.
Mm.
And so the book, which is next on, it's essentially written, and the books are illustrated by my really talented, super talented son, who's an artist, but he goes at his own pace. So the book is ready, just waiting for a few dozen illustrations.
Lovely. What's the title of that book?
Well, um,
Pending.
I'm excited. Yeah. So for me, finding truth is highest on the list.
Okay.
And obviously, I might be wrong. Might be wrong on everything. But I think I make a cogent argument in different realms.
Wonderful. Well, look, again, I can't wait to read that. There'll be a nice selection of reading for the summer. I'm looking forward to it. Let's get into energy then. Let's get into sort of practical applications of how this can change what people do on a daily basis, maybe to better their health. So, firstly, do you think everything we've just unpacked in the last sort of 40 minutes? Do you think that holds answers to a lot of the chronic diseases that are rising throughout the world? And if so, how can we go about using this information to better our own health?
Well, I think yes. I mean, first of all, if you want to conquer disease, um, without knowing how the body works or the cells work, it's going to be difficult to do it, right? It's like the analogy of fixing your car. If you don't know what the pistons do and a spark plug or whatever, it's not going to be easy when your car breaks down. If you don't have a mechanic or someone who knows about it, you simply don't know what to do, and you could try and not succeed. So if we're on the right track, and obviously I think we're on the right track, otherwise I wouldn't be pursuing it. But once you're on the right track, then a lot of things fall into place in a simple way. I'm now I've been working on the idea, the theory that disease, for the most part, is simply lack of easy water in your cell. You might call it dehydration. Now, when you're somebody my age and you've got a lot of wrinkles, you're dehydrated. People your age are pretty well hydrated. Kids that are born, they're 90% water by volume. And when you get to be my age, maybe 60% by volume. And that dehydration shows up in the wrinkles. Now, when people get older, there's a tendency for them to get sick in so many different ways, and I argue that the sickness is a manifestation. I hate to say dehydration because it sounds so trivial, but it's not so trivial when you think of dehydration as a lack of easy water in each one of your cells. Now, the easy water, as I said, it typically requires a hydrophilic surface, but not all hydrophilic surfaces build easy water. So ordinarily, in our cells, the cells are filled with proteins. That's the major macromolecule inside your cell. And the surface of these proteins are quite adept at building easy water, and therefore, or nucleating the growth of easy water, and therefore your cells are full of it. But as you get older, and you acquire mutations and such, and you're attacked by various carcinogens. There are so many of them throughout our environment. Those proteins undergo change, and the changes make those proteins less adept at building EZ. So your cells have less EZ, and you're basically dehydrated. And it's the absence or the lack of or the dearth of EZ water that leads to problems, that leads to pathologies.
Mm.
And if that's true, and I believe it's true, if it's true, it means that you should be able to reverse these pathologies if they're not serious enough by rebuilding EZ water. And there are perhaps a dozen ways you can do it. You can build EZ water. One is by drinking a lot of water, because some of that water will turn into EZ water. Exposing yourself to infrared energy in any of various ways. Drinking EZ water, et cetera, et cetera. And those should be good for health and good for repairing the various ills that you have, including cancer. So,
how does that link to cancer, out of interest?
Well, yeah, it's interesting. So I wrote a paper on this, and it's received a fair amount of attention. In fact, it's going to be the subject, or I'm going to be interviewed in a few days for a film on cancer. A film whose theme is, if you the past 50 years have been largely a failure. The war on cancer declared by our former President Nixon has not been won. I don't think anybody would argue that it's been won. And the argument made, the argument that the increasing number of people have been putting forth is, almost everything. Any studies on cancer deal with genetics, mostly focus on genetics, but if the answer actually lies elsewhere, for example, if water is centrally involved, which I think it is, you won't find the answer or the solution, because you're looking in a different realm, and the focus has been so consistent and so complete. The focus on genetic kinds of mechanisms, and certainly genetics are involved in some way, but the actual ultimate mechanism may be different. And unless you look in various different places, you may never find it.
So I'm of my a lot of people on this podcast we've had, they've convinced me that cancer occurs when there's a defaulty mitochondria, and it has to default to a different energy pathway, which is fermentation, right? Hence the Warburg effect in the cancerous cell, right? So I guess, which is the great work of Dr. Thomas Seyfried and his lab. My question to you is, what role does EZ water and the mitochondria, how do they link, if at all? How do they work in the body?
Yeah, well, mitochondria, they're factories that produce EZ water. So
right.
Yeah, they've got all the right structure and the right components and the right electrical potential, et cetera, et cetera. So when the cell undergoes a phase transition, when it goes into action, and the EZ water turns into ordinary water, it's got to go back again, and the rebuilding of the EZ water is an energy requiring step, and it's helpful to have a factory right nearby that produces the goods that you need. And the mitochondria do exactly that. And that's why in muscles, for example, there are a lot of mitochondria, because you need to replenish the muscle with energy and structure. And that's what the mitochondria do. So yes, the mitochondria are absolutely tied to this process, but they're not the, how should we say, I think they're not the ultimate issue that's involved. The ultimate issue is EZ water. So there was how to put this in a way that's simple and understandable. So there's a guy 50 years ago, Clarence Cohn was his name, and he was a prominent cell biologist. And he was asking the question, what is it that makes cells divide? Uh, and he found that it was the electrical potential. So cells ordinarily, most cells have an electrical potential difference from inside to outside, 50 to 80 or so, or 90 millivolts. Cancer cells have potentials of 10 or 20 millivolts. And he found if you take an ordinary cell and you force the electrical potential for some length of time to go from, let's say, minus 50 or 60 down to minus 10 or 15, it'll just keep dividing. And you can take a cell that likes to divide and increase the potential way up to 100 millivolts or more, and it won't divide anymore. And this has now been confirmed by numerous groups. So it looks like the electrical potential is very important. Now, what is the electrical potential? Well, I argue that the electrical potential is caused by the negatively charged EZ water. Now, there's probably almost nobody who would agree with me, but I think my arguments are cogent that the pumps and channels that are theoretically responsible for establishing the potential is impossible. I won't go into it because we have limited amounts of time, but I've published on this, and anybody could look and see see if my arguments are cogent. I'm not the only one who thinks that, but the majority of people have assured themselves that it has something to do with membrane pumps and channels. I think it has to do with the fact that the negatively charged EZ water is filling the cell, so you get a negative potential. If you don't have a lot of EZ water, then the potential magnitude is small. Instead of minus 60 or 70, maybe minus 10, because it arises from the EZ water.
Yeah.
So it means that if you can take the cancer cell or a cancer patient or so and restore EZ water by any of a number of straightforward means, you ought to be able to reverse the cancer. And many of the phenomena that do build EZ water do reverse the cancer. So that's what I am thinking is really going on in the cancer cell. And also, people with cancer have no energy. Well, if the energy, a good part of the energy comes from the water, the electrical charge of water, but you don't have much of that, you're not going to have a lot of energy. Wow. So that's where I'm heading at the moment.
So, okay, well, I mean, it's very fascinating. But when it comes to energy day to day, what effect does grounding, do Wi-Fi? I'm trying to think of all the different electrical influences we have from the external. How can they affect our internal electricity in the EZ water?
Well, grounding and Wi-Fi may be opposite.
Yes, exactly.
So grounding. So most of us wear leather shoes, which insulate us from the earth. A few hundred years ago and beyond, barefoot was more common. So we'd be electrically connected to the earth. Now, why does that matter? It turns out, to my great surprise, when I found out that the earth is negatively charged. I began my career studying electrical engineering, and no professor ever even hinted that the earth was anything but neutral, that if you put a plug into a wall receptacle, that third prong was connected to an infinite sea of bland negativity, zero potential, but the evidence is opposite. And I remember distinctly when I was told by a Russian guy working in my lab, a pretty senior guy, he was telling me about the electric field of the earth. I said, Andre, you must be talking about the magnetic field. I never heard of an electric field of the earth. He said, you never heard of it? He said, every Russian middle school student knows or knew, they don't teach it anymore, knew that the earth was negatively charged. I went home, I was scratching my head thinking, oh my goodness, I'm really confused. How could this be? How could I never have heard about it? So next morning, one of my students hands me Feynman's lectures, famous lectures by the great Nobel physicist. Volume 2, Chapter 9 is filled with evidence about the Earth's negativity. It's just that it's not considered to be significant enough or important enough for us to think about it. Um, but the evidence is there, and you can either ignore it or pay attention to it. So if you pay attention to it, you realize that the Earth is negatively charged, and if you connect yourself to the Earth and some region inside your body doesn't have the requisite negative charge that would be conferred by the easy water, the negative charge will diffuse into that region of your body, convert the liquid water into easy water, and we showed that in the laboratory. That's exactly what happens when you pass the current or pass electrons into the water. So all you're doing is doing what we did in the laboratory, doing it in a natural way. Take off your shoes, connect your feet to the wet grass or to the sand near the edge of the ocean, or something like that, or immerse yourself in a mud bath, and you're connecting yourself to to ground, negative ground, not zero ground, but negative ground. And then the electrons infuse into your body, and it's like filling your gas tank. You're filling your cells with a negative charge.
Wow.
And you feel better. And that's why when you walk at the edge of the ocean for a half hour, you feel good. Usually, I remember once growing up in New York in the summertime. It's beastly hot and everybody's at the beach. So I went with some friends, and for fun, we were 10 years old or whatever. We buried each other. And I remember getting buried in the wet sand near the water. And I remember such a feeling of immense bliss. I didn't want to get unburied. The tide was coming in, I might drown. They thought it was time to extricate me, but I just didn't want to get out of that,
Wow.
having been buried. Such a wonderful feeling of bliss. So I think that's what's going on with grounding.
It's funny
Uh,
you
you
remember
know,
that memory and it's so significant to you, right? It's almost
Absolutely.
pivotal. So, okay, fine. So, if we want if we want our easy water to be as charged as possible and as healthy as possible, would you say the top three things you can do would be make sure you try and ground yourself every day, drink enough water, and expose yourself to near infrared light?
Well, those are three. I'm not sure which of the three. Um, is most important. There are other things you can do too. For example, there are substances, herbs mostly, that have been known since Ayurvedic times to be good for health. Like turmeric is now widely advertised as such. Holy basil is another one of those, and ghee, clarified butter, and a whole bunch of others. And we tested them. Coconut water is another. In the laboratory, we found that each and every one of those actually they build easy water. Um,
Wow.
yeah, so it means that by taking these herbs, you I mean, if the body does what we found in the laboratory, it means you're building easy water, and that is perhaps the reason why they're good for your health. So that
Mm.
another expedient. Yet another one is juicing. You go to your backyard, you check out some freshly grown leaves, you pull the leaves, you smash them to squeeze out the water, and there are machines that you can buy to do this, and you drink the water. The water is the same as the water. It's the water from inside the plant cells, and freshly grown plant cells are just filled with easy water. So you drink easy water directly, and you build easy water in your own body, and you transfer it from the plant to yourself. So
Wow.
hyperbaric oxygen therapy is another.
Mm.
You insert yourself into a chamber that applies higher than atmospheric pressure and also high oxygen, 100% oxygen. And we wondered why hyperbaric oxygen therapy is so effective for so many different syndromes. And the answer, it turned out, well, I think the answer based on our results show that both high oxygen and high pressure both increase the amount of easy water. Um, and we understand why it fits, but I don't need to go into it. And so by by exposing yourself or inserting yourself into one of these chambers, you're basically building easy inside your body. So that's yet another expedient to cure basically whatever ails you.
Mm.
So
Well,
it's a yeah. Go ahead.
well, I was going to say there's a lot of interesting research coming about the hyperbaric oxygen and cancer, that would support what you were saying around cancer earlier as well, which is fascinating for sure.
Yeah, absolutely. Yeah, my late wife, she underwent that kind of therapy. Unfortunately, it was too late in the course
Oh,
of her cancer.
I'm
But
sorry to hear that.
yeah, well, that was 5 years ago. But yeah, so the bottom line is that this presents this new paradigm, offers or presents a new way of approaching pathologies, including and especially cancer, but other pathologies as well.
Wonderful.
The approach is different from the today's approach, which mostly involves pharmaceuticals.
Yes.
Uh,
Yes, and as you said, there hasn't been a lot since Nixon declared his war on cancer, right? I think.
well, there've been
Maybe,
some, but
yes, yeah,
nothing like we might have expected. Yeah.
very true, very true. My last question for you is: if you could run any experiment you wanted to, funding isn't an issue, research participants is not an issue. You got a magic wand, you can have all the design parameters you want. What experiment would you want to conduct, and why?
Oh my goodness. Okay. Well, I have to go out on a limb here to
Please do.
tell you the truth. And uh, well, I have a little fear about saying this because um, I think it may be taken in the wrong way. Um, I, I've become convinced that there's a good possibility that we undergo transmutation of elements. Now, uh, I not only we but living creatures, and and I know the reaction of many people is this guy is so off the deep end that that he can't possibly be right in any of the things that he's espousing because because we all know that transmutation of elements is impossible. Um, but you have to remember that Newton, for example, was very much into the idea of transmutation, of one element converting to another.
In
And
his search for alchemy,
yeah, well, it's basically alchemy. You can
right?
consider it alchemy, changing lead into gold,
Right.
but more generally, changing one element into another. Uh, and there's a book out by a well-known Frenchman published about 50 years ago. It's called Biological Transmutation. The guy's name is Louis Kervran, Kervran. And if you read the book, you'll find mounds and mounds of evidence um, for one element transmuting into another. And I would like to follow up on that and to do experiments and see if it's really occurring. There are some plants, for example. I've got a plant just sitting opposite me here, amaryllis plant, and I look at it and uh, it's been the same for 20 years. It's in the same soil. The soil hasn't changed. It gets watered with fairly pure water. And it has, like other plants and animals, it has virtually every element in the periodic table it contains. Some of them in traces, and some of them in uh, major supplies. And the question is, well, where does it get all those elements? How does it acquire them? And it's not so obvious how it acquires them because it just, it's exposed to the same soil for 20 years without any change and any addition. So it's kind of unlikely. And the water contains, well, maybe a few trace elements. And the air, we know what the air contains. So how does it get all those elements? A possibility is by transmutation. Now, I don't argue that it's for sure, but I would argue that it's really important to do experiments, to do more experiments, and find out. And the one the one classical experiment was sort of like the chicken and the egg. So some people notice that when chicks lay eggs, the shell is hard, and everybody knows that in order to have hard shells, just like hard teeth and hard bones, you need calcium. But they noticed that the chicks were pecking, eating on ground that had no calcium. So they scratched their head and said, well, what's going on here? How is this possible? So a few different groups in succession did experiments where they put the chickens in cages and they deprived them of one element at a time to see. So the first thing, you deprive them of calcium, but they still produce hard eggs, so something is going on. Uh, and so they deprive them of one element at a time, going down the scale. And I'm not sure if I'm remembering properly, but I think it was um, I think it was potassium, that when they were deprived of potassium, the eggs came out with soft shells. So
Hmm.
they deduced that it must be. If calcium is really necessary for this, it must be that the potassium is undergoing transmutation to calcium. Um, and that experiment has been repeated several times. And this is the kind of experiment that is interesting,
It's
because
sort of it's
it
kind of
suggests,
alchemy.
yeah, exactly. And it was so alchemy, if you want to call it that, or transmutation, was popular. A popular idea until the time of Lavoisier, this famous French scientist who discovered oxygen and more. And he said, no, it can't be. And by the way, it was around the time of the French Revolution, and he lost his head uh, because he was a hated tax collector, but also a well-known scientist. And he said, no, it can't be. And ever since then, scientists were fearful even to mention the word transmutation, because they're going to be dismissed as a quack or crackpot or something like this. But you asked me, and I'm giving you a sincere answer. This is one of the experiments that I think really, really needs to be done carefully by multiple groups. And if we got the resources, I'd like to do it.
Well, look, I sincerely hope you do get the resources to do this study and as many studies as you want, because you're a fascinating man and should be given all the resources to do as many studies as you want. What
Oh, thank you. Yeah.
how does one contribute to your studies? How would that happen? Is there a link we can find on your website? Like, if people listening want to contribute to your work in any way, where can they do that?
Well, the best way is to contact me, and my email address is all over the internet, so it's not hidden. GHP at uw.edu. The best way is to contact me, and of course, we would be hugely appreciative, because getting money for ideas that run against the mainstream. If you put it in an application to one of the government agencies, the application will be reviewed by uh, people who are mainstream people, and essentially you're challenging their point of view. So their reactions are not going to be very favorable, and most scientists know that. So if they have ideas that run counter to the mainstream, they withhold them because they know that there's almost no chance of getting funded. So you depend only or mainly on private donations, and we've received some, but from some thoughtful and generous people. But in order to do the experiments that we'd like to do, we need substantially more.
Mm.
Um, and
Well, it does spark a thought of there's a gap in um, there's a gap in philanthropy or in charity work and donations of non-consensus ideas. I mean, a charity based around doing charity events specifically to fund non-consensus ideas that could offer some non-linear leap in some way, shape, or form could be kind of interesting.
well, yeah, and there are such groups that meet on a regular basis. I'm aware of them, but mostly they they attract people who are doing the experiments, not people who might be interested in funding the experiments.
Yeah.
So that's, but there are a lot of people out there, who are really seriously interested in fundamental science. And we also, we founded a group called the Institute for Venture Science, which is an organization that's specifically designed to fund ideas that counter the mainstream views, cogent ideas, crazy ideas, but well reviewed and well vetted ideas. It's ivs.org is the website, and we'll see what happens with that. But
Absolutely.
obviously, we can't fund, since I'm the executive director. It wouldn't be fair to fund our own group. So we can't derive support from that organization.
Okay, understood.
Unfortunately, yeah.
Well, we'll put that in the show notes. Where can we find you? Where can we keep up to date with your work?
Well, pollacklab.org is the website, and um, I must say it's slightly out of date because we have so many things to do that we haven't really had time to keep it up to date.
Okay.
Apologies for that.
Well,
Yeah.
we'll put links to your books, and we'll make sure we find all your links and we put it in the show notes. Dr. Gerald Pollack, thank you so much for coming on. That was a real pleasure. I've learned loads, and
Well,
you're a fascinating man.
thank you, Ben. I really appreciate the opportunity, and it's been fun.
Yeah, super fun, super fun. Well, look,
Okay.
enjoy your day, and thank you so much.
Okay, take care.